So we've made a kit in which we can guide the tourists at various tourist places. So the principle on which this kit works is that this is a transmitter. This is a transmitter which can be placed at different locations at a tourist place or a venue, and this is a receiver which will be carried by the tourists. So whenever there is a tourist who is carrying this receiver, and whenever he goes to a particular place, the corresponding transmitter will send the information to this particular receiver, and that'll be displayed on the LCD screen here. So for example, as you can see right now, we have made 4 switches. So there can be totally 16 locations that can be shared on this LCD. So if I switch on one location, as you can see, as soon as the receiver comes close to this particular location, the display gives the details of the particular location. So as you can see, you can change the locations, and the locations can be updated as and when the receiver goes near the particular or corresponding transmitter. So we've used radio frequency modules. So this is the transmitter, and here is the receiver of the radio frequency module, along with an encoder and decoder ICs, and the microcontroller that has been used is the 8051 microcontroller, and this is the dot matrix LCD. So you can order this kit from our website, kidscrew.com, where you'll find 2 versions of the kit. One where you'll get the ready-made kit, and the other one where you'll get unassembled kit, set of components which you can assemble and solder with the help of our video tutorials. So in this section of the video, we'll see what all components are used in this kit and how to assemble those components on the PCB, and then what are the functions of each component, and then how do we test the power supplies, the exact power supplies, and then how do we convert these set of components into a complete working kit. So as you can see right now, we have the ready-made kit here for reference, with the help of which we'll assemble all the components kept here on this blank PCB. So starting off with this transmitter circuit. So we have this blank PCB here. Now a PCB has 2 layers. This is a top layer and this is a bottom layer. So the top layer is where all the components are inserted, and the bottom layer is where the copper tracks are present. So the technology that we use is called through-hole technology, in which we drill holes from the top and throughout the PCBs and solder the components at the bottom. So as you can see, this is a transmitter circuit. So here's a 2-pin connector for the power supply, and then a diode in case the wrong polarity is given, so in order to rectify that, and then a voltage regulator IC to convert the input power supply to 5 volts, and then you have the encoder IC. So whatever input is given through this DIP switches, the IC encodes it and then transmits it through the transmitter. So this is the RF transmitter. So now we'll see how do we assemble the components onto it. So for reference purpose, I'll keep my blank PCB in line with the ready-made PCB, so that we can know the exact directions and alignment of each component. So first we'll insert this 2-pin connector. So while inserting, you have to ensure that you have to connect it in such a way that the red wire is on the right side towards the inner side. And then we need to connect a diode. A diode is used to rectify the power supply in case the power supply is given in opposite polarity. So while connecting the diode, you have to ensure that the negative side, that is the side with the gray dash or the gray color on the body of the diode, is on the right side. So that indicates that is a negative terminal. So the current flows always from the positive to negative terminal. And then voltage regulator IC. So this is a voltage regulator IC. This is a front face which has all the specifications written on it. So on the left stem is the first stem, that is the input. Then the center one is the ground, and the right one is the output 5 volts terminal. So while inserting, we have to ensure that the front face or the main face is facing us or facing you. And then before inserting the IC, we need to insert a resistor of 1 mega ohm. So you have to remember that for every transmitter we use a resistor of 1 mega ohm, and for every receiver we use a resistor of 51k. So that will be provided, the specification sheet will be provided along with the PCB. So after inserting the resistor, this is the IC base. In order to insert the IC, the encoder IC, so you'll notice that there's a notch on the IC as well as the IC base. So if you keep the IC with the notch on top, the top left pin is a pin number 1, and then you need to count the number of pins counterclockwise. So the right top pin will be the pin number 18. So we always use a base in order to protect the IC during soldering, and also in case you need to replace the IC in the future, you have to it helps you to replace the ICs in the future. So while inserting the base, you have to ensure that the notch is towards you. Okay, and then the IC can be inserted on top of it. Then a network resistor is used. This is a cluster of 8 networks or 8 resistors of 10k each. So when you take a look at the network resistor, there's a dot on the resistor. So while inserting the network resistor, you have to ensure that the dot is towards you. The end of the dot is towards you. Then there is a DIP switch, which is used for the input. So the alignment has to be considered. So this is the numbers 1, 2, 3, 4 comes on the inner side. So this is how it has to be inserted. And then the transmitter. So when you take a look at the transmitter, there are 4 ends or 4 terminals. So the terminal with the antenna written on it is towards the antenna wire. So as you can see, this is the antenna wire. So there will be a small provision given for the antenna wire. So the antenna terminal will be positioned near the antenna wire. And so this completes the transmitter circuit. So as and when you keep assembling the components, you need to solder them. So now we'll come to the main PCB. This is the main PCB. So in this PCB there are 3 or 4 sections more or less. One is the section of the power supply, then the main microcontroller, then the decoder section, and then the section of the LCD. So we'll start off with the power supply. As you can see, there's a power jack given here in order to supply power through an adapter, a 12 volt adapter. And then there's an on-off switch. This is used to switch on and switch off the circuit. So this doesn't have any polarity, so you can fix it as and how you want it. Then there's a bridge rectifier. As you can see, this bridge rectifier is used to convert the AC input in case you give a power supply through a transformer. So this bridge rectifier converts the AC input into a DC output. So as you'll notice that it has 4 terminals, 2 AC input terminals and 2 DC output terminals. So the DC positive output terminal has a stem which is the longest. So while inserting, we need to ensure that the positive terminal is on the top left side. As you can see, that the positive terminal is on the top left side. And then this bridge rectifier generates pulsating DC. So we need to convert that into smooth DC. For that, we use this capacitor of 1000 microfarad. Even this has polarity. This is an electrolytic capacitor. Even this has polarity. So this stem which is longer in length is the positive terminal. In case both the stems are of equal length, there is a strip on the capacitor which shows that is a negative terminal. So this is a negative terminal. So while inserting, we need to ensure that the positive terminal of the capacitor is in line with the positive terminal of the bridge rectifier. So the positive terminal is towards the right side and negative is towards the left side. And then we insert a voltage regulator IC. So while inserting this, we have to ensure that the rear face is facing towards us. And then we have a power indicator LED. So even this LED has a polarity. So the stem which is longer in length is a positive terminal. In case both the stems are of equal length, you'll notice that on the bulb, at the negative terminal, the bulb gets flat. Otherwise it's usually round, but at the negative terminal it gets flat. So while inserting, we have to ensure that the negative terminal is towards us. So this shorter stem will be towards us. And then with the LCD, with the LED, we provide a 1K resistor of with color code brown, black and red in order to protect the LED. Okay, so this completes the section of the power supply. And then we'll fix the microcontroller. So before inserting the microcontroller, we'll insert the base. Now you'll notice that the notch is on the right side. So this is a 40 pin microcontroller, and so this is a base. Then this microcontroller works on a clock frequency. So we use a crystal oscillator of 10 megahertz. And in order to generate the oscillation, or in order to start the oscillation, we use two capacitors of 33 picofarad in parallel. Then we use a reset switch. Now this is an on-off switch. So when you press it, this is a micro switch. When you press it, it will become on, and when you release it, it becomes off. So this is used in order to reset the microcontroller, and we need to pull down the switch. For that we use a resistor of 10K, color code brown, black and orange. Then we use another 2-pin connector base, so in order to fix the buzzer. So while inserting the buzzer, we need to ensure that a buzzer has two terminals, a positive terminal and negative terminal. The positive terminal has a stem which is longer in length, as you'll notice. So while inserting, we need to ensure that the positive terminal is away from us. So the positive terminal is towards the outer end. So you have to insert the base in such a way that the positive terminal is towards the outer end. And then we'll fix the receiver. This is the receiver, RF receiver. So this is the antenna end, as you can see. So when you look at the receiver, here is the antenna end. So the antenna end will come here on the right side. Then we'll insert the decoder base. So while inserting, the notch has to be kept towards you. On top of this decoder base, you'll have to fix the decoder IC, and then the address switch, the DIP switch. So this the alignment has to be correct. So the numbers are on the right side. So you have to insert it in such a way the numbers are on the right side. In case you reverse the switch, you'll have to do the connections on the transmitter circuit also in reverse manually. So you have to ensure, you have to be careful about the alignment of the switch. Then another LED is used here. This is to indicate whether any signal is coming from the transmitter. So while inserting, you have to ensure that the negative end is towards you. And along with this, another resistor of 1K. And as told earlier, there is a resistor of 51K used for the decoder at the receiver circuit. Then a potentiometer is used. This is a potentiometer of 10K. So this is used in order to control the brightness of the LCD, here. And then in order to connect the LCD, we first insert a male birth strip. This is a male birth strip, male part. So this has to be inserted here, and then this is the female part. The female part is inserted into the LCD, and then it has to be soldered and mounted onto the male part here. So this finishes the connections on the PCB. So now we'll check the power supplies and how the power supplies have to be controlled. So before connecting the ICs and the LCD, we have to first check the power supply. So for that, first this is a digital multimeter. So we'll check the power supply through a digital multimeter. The black terminal is the negative terminal and the ground, and the red terminal is the positive terminal. So the ground is connected to the body of the voltage regulator IC. And first we'll check the input on the first terminal. As you can see, the input value is the input signal that you have given, and the third pin should show 5 volts. Okay, the 40th pin of the microcontroller should show 5 volts. The second last pin on the LCD should show 5 volts. Okay, and then you need to connect a battery here to the transmitter circuit, and then you'll notice at the input it should show the voltage of the battery, and the output should show 5 volts on the third terminal. And so once you've checked all the power supplies, you can carry on and fix all the ICs and the LCD. So you can order this kit from our website, kitsguru.com, where you will find 2 versions of the kit. One is where you will get a complete ready-made kit as shown here, and the second is where you will get all the components separately with the program microcontroller along with the data sheet and the specification sheets. And with the help of these video tutorials, you can assemble those components and solder them.